Hey folks, how you doing? We're on page 89. We're looking at number 7. All right, so we've got stoplights. Cariann's going through a bunch of stoplights. Okay, so we know probabilities for each light of her getting stopped. So remember, this is about her getting stopped. There's only two possibilities. Either she stopped or she didn't stop. So let's go ahead and start making a probability tree. That's for part 1. All right, so first possibility, first light, stop or no stop. Second light, stop or no stop. If I got stopped the first time, well, I still have the possibility of getting stopped or no stopped in the second time. And then the third one, it's a stop and no stop, stop and no stop, stop and no stop. All right, so this represents all the possibilities. All I got to do is fill in all the probabilities. And for this one, it's actually kind of nice because they're all pretty straightforward. It's 0.4 and 0.6 for the first light, 0.8 and 0.2 for the second light, 0.3 and 0.7 for the third light. And they're the same all the way down the row. So it doesn't make a difference what happened before. It's going to be 0.3, 0.7, 0.3, 0.7. Okay, so that's a probability tree. You don't have to show all the probabilities for all the different outcomes. If you just do this, that's a probability tree. So now part 2. Find the probability that Cariann has to stop at each of the first 2 lights, but does not stop on the third. Alright, well there's only one situation like that in our tree where she stops, and then doesn't stop. And that goes along this branch here. And so you'll see we got a probability of 0.4 and then probability of 0.8 and then stopping is 0.7. And all I got to do is multiply those guys together. And I'm going to get 28 over 125 or 224. That should be a 125. All right, so now part 3. Find the probability that Cariann stopped at exactly 2 of the 3 sets of lights. All right, so look for our scenarios. Now you see that above in part 2, that is stopping at exactly 2 lights. So we already know that. But she also could have stopped and then didn't stop and then stopped. And then she could have not stopped and stopped and stopped. And those are really the 3 different ways this could have happened. Well, we already know the probability for the first one. It's 0.224. And now we look, okay, so stopping and then not stopping and then stopping again. So it's 0.4 times 0.2 times 0.3. Now, the last one is not stopping, but then stopping twice. So that's going to be 0.6, 0.8, and 0.3. And don't forget, we got to add these. All right, so these are the only 3 ways that it could happen where she stops twice. And so we just multiply the individuals and then add them together. And when we do that, we should get 0.392 or 49 over 125th. All right, so 4. In 4, find the probability that Cariann has to stop at the first set of lights, given that she stops at exactly 2 lights. All right, so let's write that down with the formula. That's the probability that she stops given she stops at exactly 2 lights. All right, so the probability that she stops at the first light given that she stops exactly twice. All right, now the way this works is we got to find the probability of her stopping at the first and then stopping exactly twice. So that's the probability of her stopping first and then stopping exactly twice. And then we're going to divide that by the probability of her stopping twice. Well, you know that we just figured out the probability of her stopping twice. We did that in part 3. So we already know the bottom part of this fraction. It's going to be 0.392. The denominator for this is going to be 0.392. So now all I gotta do is look for any situations where she stops first and stops twice. Well, again, if you look at the very top, that's stopping first, and she only stopped twice. So we know that that's one possibility. All right, that's 0.224, stopping twice and then not stopping. That's 0.224. And then we have to see if it happens any other way. Well, yeah, here she stops and then doesn't stop and then she stops again. That's stopping twice and stopping the first time. So we gonna put that probability in there. And see, now all we do is add those numerators together and divide by 0.392, and we should get 31 over 49, or 0.663, three significant figures. All right, and double checking to make sure we did all the stuff. Looks like we're good. All right, thanks for watching.